Hello everyone, my name is Gaurav Kumar. I'm from class MCA first semester. My topic is number system and its conversions. So let's talk about number systems. What are number systems? So the number system is nothing but a way to represent numbers in mathematics and computing. It defines how numbers are written, stored and processed. There are four commonly used number systems. We can see binary, decimal, hexadecimal, and octal. These are four commonly used number systems. So let's see the types of number systems. The first type is decimal numbers. So what are decimal numbers? We represent decimal numbers from base 10. It contains digits 0 to 9. And it is the standard system used in daily life. We use in daily life. Each digit represents a power of 10. For example, if we talk about 573 base 10, then each number is weighted to the 10 to the power of something. So if we talk about 5 is weighted 10 to the power 2, 7 is weighted 10 to the power 1, and 3 is weighted 10 to the power 0. Okay, so when we add this all things, then it will be equal to 573. So this is decimal number systems. We can see 8, 7. We can represent 8 is containing the weight of 10 to the power 1, and 7 is containing the weight of 10 to the power 0. Same thing. Binary numbers. What are binary numbers? Binary numbers contains digit 0 and 1 in its system, and it is used in computers because they work with zeros and ones, which we can say on and off states. So each digit represents a power of 2. Example, if we talk about 1011, so 1 has weight of 2 to the power 3 plus 0 has 2 to the power 2, and 1 has 2 to the power 1 plus 1 has 2 to the power 0 of weight. It will be equal to base 11 in base 10. So it will be equal to 11 in decimal. So 1011 will be equal to the 11 in the base 10. So this is binary number. So a binary number is a weighted number. The rightmost bit is the least significant bit, LSB, in a binary whole number, and it has weight of 2 to the power 0. We have already talked about this. Equal 1, and the weights increases from right to left by power of 2 for each bit. The leftmost bit is the most significant bit, MSB. Its weight depends on the size of the binary number. So we can see the decimal number and its binary number is its equivalent binary number. So 0, we can say 000 in binary number. 1 we can represent 0001. This is 4-bit binary number. 4-bit binary number. So let's go further. Binary to decimal conversion. This is important thing. How we convert binary to decimal number. So the decimal value of any binary number can be found by adding the weights of all bits that are 1 and discarding the weights of all bits that are 0. Simply we can see that 101101. So we can multiply by its weight and add all the numbers. So we can have the decimal number like this. If we take an example 101, so we can multiply by its weights, like 1 contains the weight of 2 to the power 2. Let's delete this. So 101 is 1 contains the magnitude of 2 to the power 1 plus 0 contains the weight of So for example, if we see 101, it contains weight in the power of 2, contains weight 2 to the power 0 left right. It contains weights, it has weights. These numbers have weights. These numbers have different weights. If we talk about 1 have weight of 2 to the power 0, 0 have weight of 2 to the power 1, and 1 have weight of 2 to the power 2. So then it will be equal to 1 plus 0 plus 4. So this will be equivalent of 5 in decimal number system. So like this we can convert any binary number to a decimal number. Decimal to binary conversion. One way to find the binary number that is equivalent to given number by given decimal number is to determine the set of binary weights whose sum is equal to the decimal number. For example, decimal number 9 can be expressed as the sum of binary weights as follows: placing ones in the appropriate weight position 2 to the power 3 and 2 to the power 0, and zeros in the 2 to the power 2 and 2 to the power 1 position determines binary number for decimal number 9. For converting decimal number to binary conversion, there is a short and simple way. So if, for example, if we want to convert 12 into binary number, we will simply take LCM of 12 and we will divide by 2, because we are converting binary to decimal, decimal to binary. For converting decimal to binary, we will simply divide by 2. If we are converting decimal to octal, we will divide by 8. If we are converting decimal to hexadecimal, we will divide by 16. So, and we will write remainders in this side, So 2, 6, 12, remainder is 0. 2, 3 is 6, remainder is 0. 2, 1 is 2, remainder is 1, and this is 1. So we will write it from down to up order. So we can represent 12 to the, we can write this 1100. We are writing this from down to up order. 1 is 1, 1, 0 and 0. So writing in this order, writing remainders in this order will give us the binary number equivalent to 12 in decimal. So like this we can find the binary number from a decimal number. So this is decimal to binary conversion. Hexadecimal numbers. So what are hexadecimal numbers? Hexadecimal numbers are, this contains 0 to 15 character, 15 numbers. 0 to, we have 0 to 9 numbers, and after 9 we will represent any number. After 9 we will represent number through A, B, C, D, E and F. So we represent 10 to A, we represent 11 to B, we represent 12 to C, we show 13 to D, and we write E to 14, and F we say 15. So these are hexadecimal numbers. Base 16. There are 0 to 15 numbers and total numbers are 16 numbers. So we represent this from base 16, and it's used in computing as a shorthand for binary groups of 4 bits. Each digit represents a power of 16. Okay. So there are weights in this, the hexadecimal numbers. In hexadecimal numbers there are weights from 16 to the power 0 to increasing order of 16 to the power 1, 2 and 3 and so on. So if we talk about 16, in base 16 it will have 16 to the power 0 into 6. This 6 have weight of 16 to the power 0, and this one have weight of 16 to the power 1. If we will have another numbers in this place, then this will have also the weight is in increasing order of 16 to the power. So these are hexadecimal number. Let's move further. So for representation of 0 to 15 in decimal, we should have 4 bits of binary numbers. So we write this decimal number. So these are decimal number, an equivalent of binary number and equivalent of hexadecimal number. There are shown. Binary to hexadecimal conversion. So simply break the, so for converting binary to hexadecimal, simply break the binary number into 4 bits groups, and starting at the rightmost bit, and replace each 4-bit group with the equivalent hexadecimal symbol as in the following example. Convert the binary number to hexadecimal. For example, if we want to convert this number, we will have to group this of group of 4 bits binary numbers 0111, 01101. We can write this like this. We divided from group of 4 binary numbers, and we can write the decimal numbers. 0111 is equivalent of 7 in the binary number, in hexadecimal number, and as well as decimal number also. So we grouped 4 digits binary numbers, and we represent their hexadecimal numbers. So 0111 we can write this as 7, 0101 we can write this as 5, 1010 we can write this as A, 1100 we can write this as C, and this is equivalent of CA57, and this will be the equivalent of hexadecimal number. So like this we can convert any binary number to hexadecimal number. Decimal to hexadecimal number. So this is very simple. If we want to convert decimal to hexadecimal, converting decimal to any base numbers, it is very easy to convert them. We can simply divide by the base of what we want to convert the system, what we want to convert in the system, required system. So if we want to decimal number 17, this 17, what we can say this in 17 in hexadecimal. So what we can say is in hexadecimal number 17. So if you want to convert this 17 into hexadecimal number, we can simply divide it by 16 and write the remainder in the side. So 16 ones is 16 and the remainder will be 1. So 1 1 will be equivalent of 17 in the decimal. So we can convert this into hexadecimal, decimal to hexadecimal like this. So this is very easy. Just like this. Octal numbers. What are octal numbers? Octal numbers contains digits 0 to 7. 0 to 7 numbers in digits. Octal numbers have digits 0 to 7, and it used in computing as a shorthand for binary groups of 3 bits. Each digit represents a power of 8. Example, if we talk about C45 in base 10. So 3 will have weight of 8 to the power 2, 4 will have weight of 8 to the power 1, and 5 will have weight of 8 to the power 0. This will be equivalent of 2 to 9 in the base of 10. So we can convert octal number to the decimal like this. Simply multiply by the weights and add all these numbers. We can convert octal to decimal numbers. So this is simply we can convert octal to decimal numbers. We have talked about octal to decimal conversion. Simply we can multiply by its weight, their weights, and simply add them, and we will have required decimal number. Decimal to octal number. So this is very easy to convert any number in decimal to any base number system. We simply divide that number, from the base of that number, we want to convert on that system. So if, for example, we have 359 on base 8 and we want its on base 10 and we want this, and we want its octal number. So how we can convert this decimal number into octal number? So we simply divide by 8 and write remainder this side. So 8 into 44 will have the 44.875. This will give remainder of 7, and when we divide 8, divide 44 by 8, then it will result 5 and remainder will be 4. So when we write it from down to up order, this will be produce number 547 in the octal base. So this is how we can convert decimal to octal. Octal to binary conversion. For this is very easy to convert octal to binary number system. Simply we make the group of 3-digit binary numbers. So for example, if we have 6 to 7, if we want to convert this number into a binary number, so we can write this 7 as 111, we can write 2 as 010, we can write this 6 as 110. So this will be equivalent of the base 2. So this is how we can convert any octal number to the binary number. This is so easy. So binary to octal conversion, for converting any octal number, for converting any binary number to octal, we simply make the group of 3-digit binary number. So if we want to convert 10111, this we have to make a group of 3-digit binary numbers. Okay, this and this, and this 3-digit number are equivalent to 1 in the octal. This 3 number 111 is equivalent to 7, this 101 is equivalent to 5. So it will give the octal equivalent of 571. So this is the result from this binary number. So this is how we convert binary to octal. So we have seen every number system conversion. So we have seen what are number systems and its conversions, and thank you guys for watching this. So we have seen the binary number systems and its conversions. Thank you for watching.